So we have okay, let's get started for today's class. We have 5 assignments together before the midterm. Assignments 1, 2, and the critical pass. That's the 3 you've already seen. And right now I have finished the grading for the assignment 1, and assignment 2 will be there maybe tomorrow or the day after tomorrow, something like that. Okay, so while the grade for the assignment 1, actually I forgot to make the publish for some of the students. So if you didn't see the grade, I'm sorry about that. So I've already fixed that, so you should be able to see your grade now in the grade book. And for the assignment 2, it will be there in days, and the CPM. And then later we will have another two assignment. One is on the decision tree, which we will talk today, and the state transition diagram. Okay, all this, we only have this 5 assignments. Alright, so all those 5 assignments, they took like 15% of your final grade. So it's actually 3% each. Alright, so you kind of know the idea there. And also after the midterm, we will start doing our term project. Alright, when we are doing the term project, we will have like 4 students in a group to submit all this design documentations for the term project. And you will have that, well, I will set up the group during the week of the midterm. Speaking of the midterm, we will meet here next week. Instead, you will work on your midterm exam. You will have more than enough time to solve all the problems there. Alright, so what's gonna included is, well, like I mentioned, the critical path is definitely a part of it, and the decision tree, which I'm going to talk today, is part of it. And then other than that, it's all this concepts from this software engineering, this maybe modeling process, this kind of a concept in this week's, and the introduction to software engineering, like those concepts, what is software engineering, things like that. So from unit 1 and unit 2, okay, all these concepts may come from there. All right, and well, concept, it's gonna be fill in the blank and the matching, multiple choice, this kind of thing. And for the CPM, you are actually working on solving the problem and also the decision tree. Okay, hope that help you with your review of the midterm.
If the term is online and
it's online.
And you don't need to come to class next week.
No, you don't have to come to class to take the exam. It's online, and it's gonna take, I think I set up 2 hours. It's more than enough. So it will be available throughout the week, next week. Okay, so you will you will have 2 hours to work on that. Once you start it, there's a timer, so you have to finish and submit that within 2 hours. Okay. All right, but it will be available throughout the week. Okay. Yeah.
Okay. So we just have the midterm, and then we have our course project, right?
Yes.
So if we do bad on the midterm, does that mean like our grade won't be good?
No, actually, well, if we take a look at the syllabus, well, midterm is, I guess, 30%, right? It depends how bad it is. It's like 0, so it's gonna be which not gonna happen. It's not gonna happen. Okay, well, if it's yeah, if you got like 80% of it, well, that's only 6 points deducted, right? If it's 70%, that's only 9 points deducted from there. You still have the chance to get A. Yes?
How many questions in the midterm?
Oh, how many questions? Well, probably it's gonna be 20-ish, something like that. 20, but it's small question, like one multiple choice. Well, multiple choices, filled in the blank. But there are some questions that quite time consuming, like the CPM, there's decision tree, because you have to solve this problem, right? So it's gonna be together. It's gonna be something like 20 questions. Yeah. And 2 hours. That's more than enough. Yeah, I'm pretty sure it's more than enough. Yeah. Actually, it's OpenNote. It's OpenNote. But if you have to check every single questions through the material, you won't have enough time. Okay. But if you can like remember something, okay, you have a basic concept there, you know how to do this, you understand all the concepts, and you know how to do the CPM, the decision trees, then you should be fine with 2 hours. But if you are saying like, I'm going to learn what is decision tree during the exam, no, that's not gonna work. Okay, you won't have enough time on that. And also for the concept, if you want to, because there are quite a lot of documentation there, if you want to locate where the answer is during the exam, probably you won't have enough time to do that. Well, but if you know, if you have a like brief idea, just on what the concept is, like what is a software prototype, what maybe how the software prototype will help you with the process. You have some concept with that, then first it's easier to locate the answer, right? And then you already have the concept, probably you won't need to locate the documentations, right? Okay, so
if we need to draw something for critical path, or we need to write something, what we should do? We can write it on paper and then take a picture.
yeah.
Is it the way we
Yes.
can do it?
Yes, we can do that.
So after the exam, we'll upload our...
No, in the exam. There will be tools you can do that. Also, yeah. Also you can use your computer. You have this painting the things, right? That'd be easier if that's easier, yeah. But anyway, just I need to see this answers, yeah. All right, okay. So it's OpenNote, but don't rely on the OpenNote. You won't have enough time if you're trying to learn things at that time, at that moment. All right. And then the term project is what we did after the midterm. Okay. Good thing is we don't have a final, so that's good, right? We use the term project instead. And also for the research project, I'm thinking about letting you read some research papers, because you're a graduate student, you're in graduate school, we need to do some research. We read papers and somehow we present those papers in the class. Okay. All right. Let's go to today's thing. So we will talk about the decision trees. Okay, we learned all those critical paths, right? Any questions on critical paths? It's not hard, no, right? Okay, so yeah, I wish I made that pretty clear, I think. So when we're talking about another thing, it's called the decision tree. Okay, so why we're using the decision tree? That's for us, that's a tool to help us to specify the dynamic requirements of the software system. Okay, so here, let's see. Well, again, I'm picking up those things that maybe needs more explanation, maybe better, maybe they can be better explained in class. But there are a lot of things that are quite straightforward reading. I wish you could do all those when you are using the other half of the class time, because this is a hybrid class, right? Okay, so software requirement system, a requirement specification. So we have a lot of ways to specify software requirements, and we all know what are software requirements, right? Can you give me a brief idea? A brief definition? What are the software requirements? What are they for?
So you can understand what you want the program to do and look like?
Yeah, something like that. We want to specify the functionalities, and first the functionality of the system. What can we do with the system? What do I want to do with the system? And also some of the requirements includes those non-functional requirements like the performance, security. That's also a part of the software requirements. And also we want to specify the software requirements with the documentation. There are a lot of motivation to do that. First, we need this kind of like a contract between the client and the development team, right? So we have this thing specified here. If you're doing this, meet those requirements, I'm going to pay you, right? So we have those documented so that we can evaluate your work. We have a thing that we can evaluate your work against, or can verify your work against, right? So when we're doing the software requirement specification, well, the most common way is the natural language. We just describe, okay, the system I need has a login functionality. I need to have a graphic user interface. Maybe I need this kind of functionality. It has to have a password, right? You have to have a password login verification functionality, something like that, right? But there are a lot of it's easy to use common language, natural language to specify them, but it's pros. But the cons of the natural language is ambiguous. That natural language ambiguous, but in order to solve that problem, we have those mathematically formal specification language, like the Z, OCL. Well, we have this. Well, I like this quite a lot because let's remove a lot of the confusions in this specification. So, and I also teach another course. It's a formal specification. Yeah, hopefully, maybe some of you will take that with me later. Okay. That's and also if we want to group the requirements, we have static requirements as well as the dynamic requirements. Okay, you can learn what the difference from the names. So static with dynamic, right? So the static requirements easy to understand. Something like, give an example, just like we need a login verification. If the password is correct, we let the user through. If the password is incorrect, no. If a password is not correct for 3 times, we will, okay, sorry, we will kick you out. It's maybe you attempt to log into some other person's account, right? Yeah. Okay. And ways to represent the static requirements, we can use indirect references. So system description with indirect reference to the problem and solution properties of the solutions are given without the specific solution method. Okay, so just a general description of that and we have reference to the solution sometime. And here's another one, recurrence relations. Well, so this is like the one of the equations specify the recursive expression. Example, okay, say f0 is 1, f1 means 1, so fn plus 1 means fn plus fn minus 1. So that with this equation, we kind of able to know what is the fn minus 1. And this is kind of another way to specify the equation. To specify this relations sometime occurred in this static requirements. Okay. And then what we are more focused on also, well, you can use expression as you can use a language, or you can use as a data abstraction. So you define the requirements by focusing on the data rather than the functions. And the data abstractions describe what data is for rather than how it looks. So it's another way. We focus more on the data. We use data abstraction, maybe what else sometimes it's abstract the data type somehow to help us to express this dynamic requirements. Okay, so there are plenty of ways to specify this. You can read through, and well, most of the time you have no problem with this dynamic requirement specification. At least you can use just a language bullet point to specify all of them. But how about this dynamic description of data? Okay. So dynamic description. One can view a system in terms of changes that occurs over time. The system is a given state until some conditions there happens to cause it to change. That happens a lot, right? And the requirements of this system must be described all possible states and stimuli. But that's actually a quite, maybe if it's dynamic, maybe there be quite a lot of descriptions there. Right. So we kind of want to have a way to help us specify that. Okay. Let's see. Alright, so in order to do that, we will introduce a concept that's called a tool, a very useful tool that's called decision tables. Right. So it will specify a system as a set of possible conditions. So rules for teaching to stimuli, rules for reaching to stimuli when those conditions are met, and specify actions to be taken as a result. So basically we have a whole bunch of conditions there. So we specify, okay, if a condition 1 is met, 2 is not met, and condition 3 is met, then what's going to happen? Or in other cases, if we have 3 conditions, if they are all met, what's going to happen? And when one of them happen, only 2 happen, 3 don't happen, 1 don't happen, then what's going to happen? So we can specify that with a table. Okay. So here's an example. look at this part. So here we have some of the well, the description of the system. Okay, it's a pricing system maybe for the airplane, for the flight airline. So if the flight is more than half full and the cost more than $350 per seat, we serve free cocktails unless it is a domestic flight. Is it clear? Well, this part is clear, right? Okay, then second, we charge for cocktails on all domestic flights. And for all the ones, well, cocktails are only served on flights that are more than half full. And let me see here. Yeah. Okay. Let me check a little bit.
So is that saying we always charge for that?
Let's see. Okay, so we charge for cocktail on all domestic flights. We still have international flights. Remember that part. Okay, so the flights we have domestic flights and international flights. For all the ones.
It's saying we always charge.
Yeah, they said here is we charge for cocktail on all domestic flights. Well, with this expression, that means yes, they charge on all the domestic flights. But the first thing, if we refer back, the flight is more than half full and costs more than this per seat. We serve free cocktails unless it is domestic flight. So with that said, probably if it's international flight and it's more than half full, we have more than and the cost is high, so we can serve free cocktails. But if it's domestic, we always charge. Yeah. And for all the ones where we serve cocktails, yeah, if this cocktails is served on that domestic flights, we charge it. Okay. And also another condition is there, cocktails are only served on flights that are more than half full, right? So kind of get this information. Still, well, that's do you think that's, yeah, it's confusing. It's quite confusing because we're not quite clear about. Still, we kind of know that if you give me a well, if you give me a very specific condition, like if it's a domestic, if it's international flight and more than half full, if it's a fully loaded international flights, which the seats cost it's 1,000. How do we charge it? Do we charge that? Yeah, they don't get charged. Yeah, because well, still we can learn those through these descriptions, but still it's not quite clear to us, right? We need to, well, when we heard that it's international, it's more than that, we need to go back and read this policies and think about, okay, maybe we should charge only half. We should charge, or we should serve it for free. Okay. So now we are doing it with another way because you are dealing with computer, right? You cannot rely on the computer to understand these sentences, well, which is already quite confusing to human beings, and it may be contradictory somehow. Yeah. So for the programmers, for the development team, they should have some tool to help them. That's when we introduce this decision table. Okay, let's directly look at this table. All right. So there are two halves of the table. So the first half on the upper level, it's the conditions and the rules. Okay, let's look at the conditions. This column, this first column at the left side of upper level is the conditions. It's this or maybe this. So three conditions. Like let me give you an example. Maybe three conditions is international flight, or the price above 230, and third condition maybe let me check. Yeah, half full. Yeah, over half full. So that's here. We put the condition here. Okay. So and here maybe in the class, another example, maybe if you do the presentation, you take the midterm exam, you did very well in the assignments, then those, if you meet all those three conditions, okay, then the actions here could be get a grade of A, something like that. Okay, and the rules here is another thing. We have 8 rules for. We have 8 now. Here we have 8 rules. I'll tell you why we have 8 later. But here, in every rule, it has a column. Okay, so Y here means it meets this condition 1. Okay, Y in the first row, and the Y here, the second Y of rule 1 means it meets the condition 2, and third Y means it meets the condition 3. Okay, and so does for this all the other rules, like rule 5, it meets 2 and 3, but it doesn't meet 1. So we specify these rules, and under each rule we will say what happens if the rule is met.
So it's like a truth table?
What table are you saying?
It's like a truth table?
Yeah, it's called, maybe it's similar. It's a decision table, so it's a table, and well, it has this certain format here. If you go to this, all right. So this is actually the rule that extracted from the description there. Right. So we have this. It is domestic, over half full, and over $350. It serves the cocktail, but it's not free, right? Think about when we are serving the free cocktail. It's need to be non-domestic, right? International, right? And it needs to be over half full, and it needs to be over $350. So that's the rules number 2. See here, cocktail is served, and it's free. Okay, so that's 2 actions: cocktail served and it's free. Okay, and there's some situation it doesn't serve cocktail. Here is a domestic flight, but it's not over half full. Doesn't have a lot of passengers there, and it's over here, then the cocktail is not served. So let's go back. That's this rule. Cocktails are only served on the flights that are more than half full. Okay, you see this part? Okay, and here there are some situations that you cannot get a clue what should happen from just the description. For example, here, if it's international and it's not over half full, if it's below the half full, low enrollment, and it has well, higher price seat, so are we serving the cocktail or not? How do you think? Well, under this situation, it's an international flight, but and the price is okay, over 350. But the problem here is it's below the only half of the less than half of the flight is loaded.
So then, yes.
Let's go back to read this paragraph. Here it says cocktails are only served on the flights that are more than half full. But let's see. If the flight is more than half full and the cost more than this, we serve free cocktails unless it is domestic flights. And we charge for cocktails on all domestic flights. That is all the ones where we serve cocktails. Cocktails are only served on the flights that are more than half full. Okay. Since this description, cocktails are only served on flights that are more than half full. This description, well, in this whole paragraph, it may be attached to the description of the domestic flight somehow. So we are not quite clear about the scope has been restricted by this sentence. It may refers to like cocktails are only served on the flights that are more than half full, including this international and domestic. Or maybe it's just referring back to the domestic flights that cocktails are only served on the flights that are more than half full. So here there are some situation which is quite unclear. We don't know if it's served, right? And here this is another unclear part. So if it's international flight and if it's over half full, but the price is lower than 350, we don't even know should we serve it or not, because it's just not mentioned in this description, right? It's not mentioned at all. We cannot infer that from the description. So from decision table, we can clearly say which policy or rules they are clear, they're quite clear. Or which are the policies there, maybe the rules there. Well, as a development team, we need to ask more of these questions from our clients. Okay, actually, I think this should be and should not be served, because this doesn't actually quite attach to the domestic. This should have the scope to all the flights. So here it might be not served. But well, like I said, it's quite confusing. Sometimes it's self-contradictory. So with this table, one of the advantage of this table is we got ourselves very clear about the conditions and the reactions. And the second value is, if there is something that is unclear and we want to figure it out, we bring this table back to the clients. Okay, we just check, okay, from your description, hey, we don't really know if it's international, over half full, and less than 350. We don't even know if the cocktails should be served or not. So can you or your manager, the policy maker, can you answer the question for me, right? So with this table, it will make all these problems ambiguous points, make all of these things explicit. Okay, so that we can just check for the answer. It helps us to check for the answer, to clarify the confusions, and make things and confirm all the things that has been very clear to us. Okay, so that's the value of this decision table. All right, But why here we have 8 rules here? How do you think?
There are 3 variables.
3 variables, yes, and then
Each one can be true or false, or yes or no.
yeah, exactly. In this case, we have 3 conditions: domestic, over half full, and over 350, right? And all of them has 2 different possibilities, 2 values, yes or no, true or false. So the combination is now 2 to the 3. So it's 8. Okay? So that depends on how many different combinations can you have. In your, how many rules is there? It depends on how many different combinations there can you have. Okay? Because we can have a domestic y, and it can change from n y, so it's 2 times 2 times 2, 8. Okay. All right. How about if we change condition 3 to 350? We have 3 different. Okay, let's change this part a little bit. If we have 3 different values for condition 3, like over 200, over 250, below 250, the third one is equals to 250, then we have 3 different possibilities for condition 3. Okay, assume this way, and then we have still we leave this first 2 conditions the same. They have 2 different possibilities. So what is going to be the numbers of rules? What is going to be the number of rules?
Maybe 9.
9? Maybe not 9. It's more than that, actually. So no, it's 2 times 2 times 3,
Oh.
right? So we will have this number of combinations. Yeah, so it's because domestic can be y and n, over half full can be y and n, but over 350 can be over, below, or equal 3 values. So we're trying to calculate how many possibilities, how many different combinations there could be. So for the first one, 2, second one, 2 times 2, and for the third one, it's 3, 2 times 2 times 3. Okay. So that's that's a mathematic there. Okay. Alright, so if that's gonna be 2 times 2 times 3, yes, 2 times 2 times 3. So and when we were counting this number of rules, we consider how many conditions are there. Okay, instead of the actions, we actually do not take them into consideration, because actions, well, it will go with different rules. It's just a reaction there. But when we are calculating how many are there, it's all about the conditions. Okay. All right. Now let's do another thing. Maybe if for the condition 1 we have y and n, condition 3 we have below, above, and equal. Condition 2 we have maybe another 3 or something else. Over half full. Okay, over half full, below half full, equal half full. 3 of them. Okay, so now it's 2, 3, 3. What's the number of rules? 18. Correct. So it's gonna be 2 times 3 times 3. So it's 18. Okay. Here, if it's all of them are 2, they are 2 times 2 times 2. Okay. Okay, now let's take this exercises. The subsidy to a Cub Scout pack is based on the number of Scouts, rank, and the length of membership. So subsidiary for each Scout is 25 for first year members, and 35 for second, 50 for the members who has a membership longer than 2 years. Okay, this 3 things easy. And in addition to this base, each Scout gets extra subsidy of 10 if he attend the rank of wolf, and the 15 if he attend the rank of bear, 20 if the lion, unless he does it in the first year, in which he receives 70. That means if you got the rank of lion in the first year, you receive an additional 70. Okay? Any question with this description? Okay, cool. So now let's see. Let's try to make a decision table there for this description. Okay, try to do it with maybe a piece of paper there. First, let's think about what are the decision variables. Let's do it together. What are the decision variables?
The numbers,
The length.
Let me. What's it? Okay, let's do this. Alright. So now we have conditions. Can you see that clearly? Okay.
Isn't it small?
Yeah, let me.
It's like a ball.
with the zoo is up.
What are the conditions here?
So the numbers that
Length of membership.
Number of
The length of membership.
well, actually the number of scope, does it matter? It's the length of the membership, right?
Time frame.
Time frame here. So for each scout it's 25 for the first year members,
There's
75 for the
one,
second year.
one
Is that
time.
well, this won't change according to how many scouts there, right? It's only change with the length of a membership. So the first condition should be the length of membership, right? And what else? Rank. Yes, actually I think it's rank. Rank, right? So now let's think how many rules are there.
Why the number of Scots was not the condition?
So what could be the, okay, if you think the number of Scots is one of the condition, what is the value for that condition? What could be a possible value for that condition? Right? Because here it says it only makes difference when you are first year member or second year member, or you have been longer than 2 year member, right? But it doesn't say that, well, the subsidy is gonna change if we have 100 Scots there, right? Or if we have 1,000,000 Scots there, right? It doesn't see that. Maybe it will change because of the budget. Because if it's million, maybe probably we don't have enough budget, but it doesn't specify here, so we don't care about that. But we just focus on what we have here. So okay. So how many rules do we have? How many? 4. Any other opinions? Four. Do you think 7? Oh, okay. Let's see. That's fine. Let's see. Okay. So how many? Okay, like I said, how many rules are there? It depends on how many different combinations. How many different combinations is there? How many possible combinations are there? Okay. So let's see. How many possible combinations are there? It depends on, well, what is the different value on these 2 variables? How many different values? Let's see. For the length of membership, how many possible values could there be? Yes, 3, right? So it can be first year, second year, and longer than second year. So there will be 3 different types of lengths. And how about this rank? 3, yeah. Okay, so rank is well, subsidiary. Wolf is one of them. Bear, second. Lion, third. 3. Okay. So we have 3 different lengths. We have 3 different ranks. What is the number of rules? 9. Yes, 3 times 3 is going to be 9. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then we have the actions. Maybe we'll do that later. Here, okay, lengths, subsidy. Okay, first let's see. So the length of the membership. First, length we could be year, 1 year, 2 year, and more than 2 year. Okay, so we'll just say 1, 2, and n. Okay. Okay, 1, 2, and n. So we have 1. So we have, let's say 1 year, 1 year, 1. 1 year. Okay, 2 second year member, second year member, and the n year member, which n is greater than 2. All right. And how about this rank? We have how many there?
Wolf, bear, lion.
Wolf, bear, lion. Yeah. So wolf, bear, lion, wolf, bear, lion. Right. So this is the table. So we have 9 different combinations. 1 wolf, first year wolf, first year bear, first year lion, second year wolf, second year bear, second year lion. The n year wolf, n year bear, n year lion. Okay. Now let's do this. So now we can calculate. If it's first year you get 25, right? And if you wolf, you got 10. So it's gonna be 25 plus 10, right? You got paid 25 plus 10, 35. And give me a number. How about second year? How about the first year bear? 40, right? 40. And the next, well, if first year, let me see, if first year 25 plus, so it's 95, right? Yeah, it's 95 because here it's a first year lion, you got 70 extra, and if you have first year you got 25, so it's 25 plus 70. On second year it's gonna be how much? 35. Where is it? 50, right? And there.
Second year was.
Oh no, sorry. It's just 25 plus. It's 40.
35 plus 10.
Oh yeah, sorry. It's 35 plus wolf. It's wolf. It's 10. 35 plus 10 is 45. And this is 50. It's 35 plus 15 is 50. And then it's well, how much is that? Third year is 35 plus 20, 55. Okay, because it's a lion, you don't have a. If it's second year you get lion, you don't get this 70, right? And if it ends year, it's gonna be 50. It's gonna be 15 more than this, so it's gonna be 60. And 65 and 70. Okay, so that's the decision table we create for it, right? Okay, do you think this decision table is more clear than the original description? Right, it is, because it makes things quite clear. We can easily check the table for what shall we compensate for all these Scots, Okay. All right. Decision table. Answer how big the decision table? What are the decision variables? Yes. What are the possible associated value for each variable? Right. We identify them. Right. These two are the variables, and 1 to n is the possible value for first variable. WBL is the possible values for the second variable. Which are the conditions? What are the variables? What are the conditions, and which variables are the actions? Yes, the actions have the money paid. That's a decision table we already did. Okay, and the decision tree. Yeah. Okay, so this is a decision tree. Well, it's just a change from the original decision table to a tree format. So it's an in-flight service. Still, it's you have all of these combinations: 1, 2, 3, 4, 5, 6, 7, 8. 2 times 2 times 2. Remember? So at the end, you will have 8 different kind of reactions. So, but here you start from the first. You start from the first variables. If it's domestic, y or n, and then if it's domestic, you check if it's full, half full. If it's half full, after this you check if it's greater than 350. So you kind of create that as a tree. This tree is easier to maybe visualize. Visually, it's easier, right? If you want to kind of follow follow a path. And if you make a tree, well, for a computer, from the perspective of programming, the tree, how do you implement that tree? We have a lot of data structures. We can deal with trees, right? A lot of trees, and we have like a red, black tree, those kind of things. And also, if you do not use data structure, you can well, that's maybe not recommended, but it's a if with nested with another if, something like that. Or switch, you have different switch. If you have more than one condition, you have a switch of 3 conditions, right? We all know what is switch, right? We all know what is data structure, what are trees, right? Okay, cool. So with these trees, we can implement that with the programming, probably, yeah.
So if you give in an exam, if you wanna give us, you will give us something like this exercise, right?
Yes, I will give you a description of this.
And we have to do after the table. We have to do the tree.
Well, if I ask you to do the tree, you will do the tree, yeah. But table is yeah. I'm sure table will be there
The table will be off.
in the exam. Okay, yeah. All right, so that's for the decision table. Okay, any questions on decision table? Yeah. Okay. So that's the thing.
I have one question
Yep.
about critical path.
Yes.
If the first node, the start node, has a duration non-zero, because all the example and exercise was the duration start was 0.
Okay.
If we don't have 0, so we have to consider, instead of 0, we have to put, for example, 3, right?
Okay, so why I put all zeros there? Because the first node is actually a dummy node. So it's not an actual process in this whole software development process. It's not the actual activity there. It's just activity like say, okay, we start doing this, something like this. Okay, we have a dummy node, start and end, they are all dummy nodes. Okay, it's not a real activity. That's why its all duration is 0. All right. Yeah. Okay, so that's the probably that's everything in the midterm exam. Okay, then I will talk about something else that is not in the midterm. But it's in the assignments, so it's gonna be this state diagram. I believe you have more or less learned this a little bit, right? State transition diagram. Have you heard that at all? State transition diagram. Okay, I can mention that a little bit, and we can talk more next time. But do we know what is a class? What is the object in class? Do we know that? Yes. Okay. So sometimes we use the state diagrams to represent the change of a class, well, the state of the class. Well, when I define a state, I mean, for example, we have this light, we have this projector. Okay, we can have different states for the projector. If it's on, right, or it's off, that's the second one, or it's waiting for something, pending, something like that. We have maybe have 3 different states for this projector. Okay, if we want to make changes, switch between this status, we can use the state diagram to help us to specify how this change will happen. All right, so let me just show you a simple example here. So we just have maybe it's on, and another state it's gonna be off, and another state I'm gonna tell it's pending, it's waiting. Then I will have two dummy node. One is the start, one is the end. Okay, so probably when we are starting this, just say we plug the cable. Probably it won't be start automatically. It will be at the off state, right? So it could be something like this. So this is the start. We start from the off status. So if you do nothing to that, it should probably be off, right? So if you kind of turn it on, you press the on button. Okay. Wait, what is the arrow I was using? This is we maybe press the on button. Right. And then when we are at the status of on, how do we transition back to the off?
Can you make it bigger? Is it possible? Then?
Yeah. Is it better? Okay, yeah. So right now when we start this projector, probably it's an off state, state, right? So when we press the starting button, it could be here, B, it will be on, right? It will be on, and no, actually, if we press that button, it will be at this state. Because there's no signal yet, right? It will be switched from the off to the waiting status. Okay. And then during the waiting, what may happen? What's that?
It's waiting, I guess, the load before it turns on.
Yeah. Okay. I mean, we're now talking about the possible chain switches between the different status, right? Because when we are doing the off, what we can do is we press on, and it's open, right? Okay. And then now it's in the waiting status. And here we have two different possibilities. First, if we press the off button, what it will do? Here, when the projector is waiting, if we press the off button, what's gonna happen? What's that?
It's turned off.
Yeah, it's turned off, so it's going which state it is? Off. Okay, so we have a possibility to go from waiting to off, right? Okay, maybe a little bit over time, but if you have something, feel free to leave. maybe just another 5 minutes. Okay. Press off button. Okay, it will be off. Okay, and what else could happen during the waiting status?
Nothing happened and it says to on.
Nothing happens? Yeah, just waiting, yeah. And what else?
Then it's turned on.
Yeah, it can turn on, right? So what makes it turn on? There's signals coming in, right? Because, well, if I unplug this cable, it will be waiting for the signal input. But if I plug in this a signal, the HDMI, the project is on, projecting whatever is on my computer screen, right? So we have another switch, possible switch from waiting to on, right? So what happened during that? The signal. Signal input. Then it's on, right? And what else can happen? Well, let's say here, waiting. Any other possibilities during waiting?
If signal is off or something happened, it's closed.
No, I mean, let's go back to waiting, the waiting state. Well, we could be off. We could be switched to on. Well, probably that's it, right? Yeah. Okay. So what happened during this on status? It can go off, right? If we press the button, and it can go back to waiting. Yes, it can go back to waiting. So it can go to off. It can go to this waiting. Well, you just need to say it's signal lost. Signal lost. Press the off button. Okay, so here's the start. Actually, we have an end note here. Well, sometimes we use the end, sometimes we don't. It could be a. Well, maybe this is not a good example of using this end. But if we design this end as, well, if it's unplugged, the power cord is unplugged, it's gonna be end. So we can have kind of, we can jump from any state to the end if we unplug. If we're in the off state, if we unplug the cord, it's gonna be end, right? If we're waiting, we unplug the cord, it's gonna be the end. Or if it's on, we unplug, the same thing is gonna happen. So we can have another 3 transitions from here to end, right? Or so, from waiting to the end. Man. Okay, fine. And also from this on to the end. But you got the idea, right? So it just tells you how many states there can be, and tells you what's gonna happen, what triggers the transition from one state to another state. Okay, so pretty simple. We have this state expressed with this square, and we have this lines with directions tells you change from which state to another state, and also we specify the condition of this change. And actually within each state you can kind of specify what's the actions in that state. Like on means project a light on the screen, something like that. You can specify that more. Okay, so this is actually pretty simple concept. What I need you to do is to read through this state diagrams while introduction. No. State diagrams introductions, and try to understand what I just mentioned. So that's easy definitions, and it's it's a good tool to modeling the system to see what is the transitions in between. Okay, we may talk more next time when we meet. Okay, but after the midterm, this is not gonna be in the midterm. So the midterm is gonna go to up to the decision table thing. All right. Okay, so that's it for today. Thank you very much, everyone.